Hello dear students, welcome to chemistry classes. In this class, we will discuss about the preparation of glycol, which is also called as ethylene glycol from ethene. And here we have two preparation methods. The first one is by passing ethene gas through cold and alkaline potassium permanganate solution, that is nothing but a KMnO4 solution. The first method involves by passing ethene gas through cold and alkaline potassium permanganate solution. Alkaline potassium permanganate solution means what? Basic potassium permanganate solution. Here we can write the equation for this one. This is ethene gas. When this ethene gas is passed through a cold and alkaline potassium permanganate solution, this potassium permanganate solution will provide a nascent oxygen. In presence of water, this ethene will get converted into glycol. This is the preparation method. We can prepare glycol from ethene just by passing ethene gas through cold and alkaline potassium permanganate solution. And here for this we can write a reaction mechanism also. When this ethene gas comes in contact with the oxygen, that is the nascent oxygen, this ethene will convert into a three-membered ring, that is ethylene oxide. And here this oxygen is having two lone pairs of electrons, and it can easily donate these two lone pairs of electrons to the other species, and here this oxygen will donate one of the lone pair of electrons to the hydrogen of water, and it will drag that hydrogen, and this hydrogen will leave the bonded pair of electrons to the oxygen atom of water only, and we will get an unstable three-membered molecule. And here I am writing positive charge on the oxygen atom because the covalency of oxygen is 2, but here it is having 3, therefore it becomes unstable. And to get stability, it will drag the bonded pair of electrons towards its center, and here this carbon, after losing this bonded pair of electrons, will remain with 3 bonds, one with the carbon and other with the 2 hydrogen atoms, hence it becomes unstable, and it will get stability by the hydroxyl ion, which is already released from the water, and this hydroxyl will attack on the electron deficient carbon atom, which results in the formation of glycol, OH. This is the reaction mechanism for the preparation of glycol from ethene. In first step, ethene will react with the oxygen to form a three-membered oxide, that is ethylene oxide, and this oxygen, which is having a lone pair of electron, will drag the proton from water and forms an unstable three-membered ring, and after the attacking of hydroxyl group to the electron deficient carbon, we will get a glycol. Okay? This is the first method. Then the second method of preparation of glycol involves by treating ethene with hypochlorous acid. Hypochlorous acid, that is HOCl, followed by the hydrolysis with sodium bicarbonate, that is nothing but NaHCO3, will give glycol. This is the second method of preparation, by treating ethene with hypochlorous acid, that is nothing but HOCl, followed by the hydrolysis with sodium bicarbonate will give glycol. And here I will write the reactions for that one. CH2, CH2, this is what ethene. When it is treated with hypochlorous acid, it will form an ethylene chlorohydrin. And this ethylene chlorohydrin on hydrolysis in presence of sodium carbonate with some amount of heat, it will form glycol. And here we will get some amount of hydrochloric acid as a byproduct. This is the reaction for the preparation of glycol from ethene by reacting with hypochlorous acid, and here it will give ethylene chlorohydrin, which undergoes hydrolysis in presence of sodium bicarbonate to form glycol. And here also we can write the mechanism for this reaction. First, this ethene will react with the hypochlorous acid, and we know that this hypochlorous acid is a polar molecule, and the bond between this OH and Cl will easily break, and this will react with the double bonded carbon atoms to form ethylene chlorohydrin. And we know that here this chloride or chlorine atom is more electronegative as compared to the carbon, therefore it will easily drag this bonded pair of electrons towards its center, and it will get partial negative charge and the carbon will get partial positive charge. This chlorine atom, being more electronegative than the carbon, will drag the bonded pair of electron towards its center, and therefore this carbon will suffer from the electron deficiency, and this carbon will get those electrons from the oxygen atom of water. This water molecule having two lone pairs of electrons on the oxygen, and this oxygen will easily donate that lone pair of electron to the carbon and forms an unstable molecule. And here the loss of chlorine anion or chloride anion takes place, and here I am writing positive charge to the oxygen because it is having 3 bonds. We know that the maximum covalency or the valency of oxygen is 2, and here it is having 3, therefore I am writing here the positive charge. And here also the chlorine, negatively charged chlorine, will drag one of the proton from this unstable positively charged molecule, and this bond will shift towards the oxygen, and it gives glycol with some amount of HCl as a byproduct. This is the reaction mechanism for the preparation of glycol from ethene by treating with hypochlorous acid. Dear students, in exam if they ask the preparation method for 2 mark, you can write any one of these two. No need of writing the mechanism unless and until they are asking to write the mechanism. Okay? Better to write only the explanation and chemical equation. Thank you.